Good morning. It's a bright and sunny Friday morning, and I'm pleased to announce that there is only 1 week left of classes. I'm thrilled. I hope you are happy too, and I'm hoping that you at least get some semblance of a normal summer. Sounds like things are starting to open up a little bit more in Alberta, at least. And hopefully that kind of continues. So I hope you've been healthy and well, and I hope that continues for you into the summer. In this video, we are going to learn how to name alkenes and alkynes. So as you watch this video or practice any of this on your own, I encourage you to open up that document I shared with you with the IUPAC Nomenclature. And we're going to use that in this video here to name this set of alkenes and alkynes. All right, so naming alkenes and alkynes is very similar to naming alkanes. The big difference, though, is that with alkenes and alkynes, we have a double bond or a triple bond, respectively. And when we name the alkene or alkyne, we need to indicate the position of that double or triple bond with a number, the carbon number at which that double or triple bond starts. So let's get started. We'll start with the first one here in the top left. It's very simple alkene. There's no branches, so this should be pretty straightforward. First thing we do is we find the longest continuous chain. Now there's a little caveat with alkenes and alkynes. When we look for the longest continuous chain, we're looking for the longest continuous chain that contains a double bond or the triple bond. So the longest continuous chain that contains the double bond, that's going to be our root. So in a straight chain, it doesn't really matter because you just have the one chain. And what I've got here is a 6-carbon alkene. And you're going to see it doesn't really matter where, from what direction I start numbering, I'll get the same name. I have 6 carbons in this chain, and the double bond starts at carbon 3. So the name of this alkene is hex for 6 carbons, 3 because the double bond starts at carbon 3. The suffix is -ene because it's a double bond. It has a double bond, so therefore it's an alkene. And that's it. Let's move on and do the top right alkene. Once again, we're going to look for the longest continuous chain of carbons that contains the double bond, and that will be our root. So I could start here, 1, 2, 3, 4, 5, 6. So if I go this way, that gives me 6 carbons. If I follow the straight path, what do I get? 1, 2, 3, 4, 5, 6, 7. So I get 7 going this way versus 6 going this way. So that means the 7 is the root, which tells me I'm dealing with a root of hept. Now I have to indicate where the double bond is found. Well, I need to number the carbons in the main chain such that the double bond occurs at the lowest possible carbon number. So by numbering it from right to left, carbon 1 shows up on the right, and the double bond then occurs at carbon 2. So double bond occurs at carbon 2, so that tells me that I'm dealing with hept 2-ene. And we have a branch. We've got a branch coming off of carbon 3. And we need to count how many carbons are in this branch. So to count my carbons, I count the points or the vertices in the line. 1, 2, 3. I've got 3 carbons. So that tells me I'm dealing with a propyl group. Prop is the root for a 3-carbon chain. And the propyl group is coming off of the 3rd carbon. So the prefix then becomes 3-propyl. To give us a alkene name of 3-propyl hept 2-ene. All right, let's move on to the next one. I'd encourage you to maybe pause the video here and see if you can try doing this one on your own. Otherwise, I'm going to keep going and solve this one. So the longest continuous chain is 1, 2, 3, 4, 5 carbons, but I should start numbering from the right because I want my double bond to have the smallest possible number. So there we go. We go 1, 2, 3, 4, 5 from the right. And you'll notice that I have not one methyl group, but two methyl groups coming off of carbon 4. So I've got two methyl groups coming off of carbon 4 and a double bond starting at carbon 2. What does the name look like? Here's a bit of a trick, some new thing that you might not have seen before. If I have two things coming off of the same carbon on the main chain, I write the number of that carbon twice, separated by a comma. So in this case, I'll write 4, 4, and indicate that I have two carbon groups, two methyl groups. I write dimethyl. So 4, 4 dimethyl indicates that I have two methyl groups coming off of carbon 4. I need to write the 4 twice because that says the first methyl group is at carbon 4, and the second methyl group is also at carbon 4. So you write 4, 4. All right, so 4, 4 dimethyl is the prefix. I have 5 carbons in the main chain, so that means my root is pent. And the double bond starts at carbon 2. So I get 4, 4 dimethyl pent 2-ene. All right, let's move on to name alkynes. And actually, alkynes are the exact same thing we need to watch for. Same protocol we're going to follow. The exception, though, is that instead of having a suffix of "ene," we have suffixes of suffices. I think suffices is the plural of suffix. We'll have a suffix of "-ine," Y-N-E, instead of E-N-E. So let's go ahead and name this alkyne on the left. If you want to try it on your own, once again, pause the video and see what the solution is by clicking play. All right, so I've got 1, 2, 3, 4, 5 carbons in this chain, and like an alkene, I need to figure out where the triple bond occurs, and it starts at carbon 2. Starts at carbon 2, and I've got two methyl groups at carbon 4, so this is very similar to the last one we did, except we have a alkyne, so we have 4, 4 dimethyl, that's going to be the prefix, and the root is pent because it's a 5 carbon chain, and the triple bond starts at carbon 2. So it'll be 4, 4 dimethyl pent 2-ine. All right, let's do the last one. Once again, the longest continuous carbon chain that has a triple bond is this one. 1, 2, 3, 4, 5, 6. Let's just double check. I could also go 1, 2, 3, 4, 5, but that's not as long as the 6 here on the main chain. So I'm going to go with this one. 1, 2, 3, 4, 5, 6. And once again, alkynes can be a little bit tricky to draw in a line structural formula. You need to recognize that the end of each line is a carbon atom, and because of the triple bond, the geometry on these carbon atoms is 180 degrees. So that's why it looks like a straight line. It doesn't bend like all the other ones, which have tetrahedral geometries. All right, so main chain is 6, so that gives us a root of hex. The triple bond starts at carbon 1, so we're looking at hex 1-ine as a root and suffix. Now we just have to deal with our branches. So off of carbon 3, I have an ethyl group. That's an ethyl group. And off of carbon 4, I have a methyl group. So let's put it all together. Ethyl starts with an E, and E comes before M. So that means ethyl is going to come first. So we're going to write 3-ethyl hyphen. You should always have a hyphen between a number and an alphanumeric or an alphabetical word. 3-ethyl, 4-methyl, So there's our prefix. Now I'll put my root in, so that's going to be hex, and the triple bond starts at carbon 1, so it'll be hex 1-ine. There you go. So it's very similar to naming alkanes. You do need to watch out for the double and triple bonds, but you are following the general rule of doing prefix plus the root plus the suffix. All right, that's it for this video. In the next one, we're going to have a look at cyclic hydrocarbons. So hydrocarbons that are rings instead of just straight chains. All right, bye for now.